Okay, now let's say that we want to train the model for all three values, 0, 1, and 2. Okay, no injuries, injuries, fatal injuries, right? So create dummy variables for each of the value of the target, build a new data set with these dummy variables, and then run the model. So we have to first okay. So severity dummy. Okay. Remember, we need this as a data frame. Okay. So model matrix. Okay. Now we want to select only one variable, so we can do this. If you say 0 plus as factor, then the intercept will not get created. Okay. As factor, what max severity IR injury. Okay. Okay, and we have to give the data. As factor data equal to, so we want to go back to the original data, ACCDF. Okay, so now that's going to create our dummy variables. Okay, so severity dummy. So the names are kind of crazy, see, as factor and so on. So let's rename them. Let's give the names ourselves. Names, severity dummy is, well, C, correct, max severity 0, max severity 1, and max severity 2. Okay. All right. Okay. Then there are a couple of ways in which we can do this. We can go ahead and build our own, like how we built the data before. Build the data and then do the partition, or we do have the trained rows already, right? Okay, so where is it? See, here are the trained rows. So we can simply partition this using the trained rows, and then we can bind it to our trained DF. So trained DF already has everything that we need. What we have to do is to simply remove this max severity, and in its place put those three dummy variables that we have created. Okay, so what we can do, and we can do the same with the valid. So we can say train.df is C bind, right? So we do train.df, but remove the last one. Okay, so right now there are 8 observations, so we remove the last one, which is so -8. Okay, and then we add the severity dummy that's a data frame, but we want only the trained rows. Okay, severity dummy trained rows, okay, all columns. Okay. So it's going to drop the last column, and in its place, select the exact same rows that went into train DF. Okay, it's going to select those rows from the severity dummy and attach those. So now I'm going to copy this and make that into valid. So again, do the same thing for valid. Okay. So this will be minus trained rows. Okay. Well, let's not. Let's create them as new train and valid. So the old train and valid would still be there in case we wanted it. Okay. So this is going to now. So let's look at train 2. So it has all of the variables that we had previously, and in place of maximum severity being just one column, that column is gone, and in its place we have the 3 dummy variables. Okay, so now we are ready to run the so we'll call this ACC NN 2. Okay, so neural net. All right, so max severity 0 plus max severity 1 plus max severity 2. So those are the 3 columns that should be used as target. So we have 3. We will now have 3 nodes in the output layer. Okay, and then data equal to train train 2 dot df, and then say we want hidden equal to, so I'm just making this up. So we can set up a control in Caret to try different values for the number of neurons. Okay, right now let's just select 2 layers, 2 and 3, and plot ACC dot N2 unexpected symbol. Okay, so I need a comma there. So here it is. So we have 3 output nodes, and then now we can predict. Okay, so using ACC NN3 out will be predict. Okay, ACC NN3 comma valid2.df. Okay. This is okay, ACC NN2. Sorry, ACC NN2. All right. Valid2.df is not there. Oh, I have valid3 here. I don't know why I have valid3. So that should have been valid2 and valid2. Okay. All right. So now what happened? Just give me 1 second. The out has 3 values because there are 3 output nodes. Now from these three, how are we going to get our prediction? Okay, so what we need is whichever column has the largest value, that will be our prediction. So we have to go through this row by row, figure out which column is the maximum value, and that column will be our prediction. Okay, let's now set up which column has the maximum value for the output. We're going to do this with which max. So which max is going to tell us which of the values is the max, the first one, the second one, or the third one. So and we have to do this one row at a time, so we have to use apply. Okay, so apply, we want to apply which max. Which max is the function that we want to apply. That's the third argument in apply. Okay, we want to apply this to this data, which is ACCNN2.out. So that's the one that has the output function values. Okay, and we want to do this one row at a time, so that's the second argument, which is 1. So one row at a time. 2 will be column at a time, so we want row at a time. So then which max? So it's going to go to the first row, okay, which is the maximum one, and then give you the column number for that value. So it'll be either column 1, column 2, or column 3. So that would be our prediction. So we can say ACCNN2.pred equal to that. Yeah. But there is one problem. It's going to give you prediction of 1, 2, or 3, but the actual values, if you see in valid.df, that's the one that has a single column. Valid2 has 3 columns, max 0, 1, and 2. So we need to look at valid. So here this has the 3 values are 0, 1, and 2. Okay, 0 is no injury, 1 is injury, 2 is fatal injury. So column 1 here refers to actually the max severity of 0. This one is max severity of 1, and this, so the column number minus 1 will give you the maximum severity. So you need to do minus 1 here. Yeah. Now if you run that, then ACCNN2pred, you see that you have values 1, 2, and 0. Okay, and then of course you can do a confusion matrix. After that, confusion matrix as factor the predicted value, which is ACCNN2.pred, and then as factor, so valid.df. Valid.df is the one that has a single column of maximum severity. So you have max severe. All right, and that gives you. So we need to make sure that the prediction and the actual values coincide. So you can't have actual value 0, 1, 2 and the prediction value is 1, 2, 3. So that's not going to work. That's the reason why we had to do a minus 1 here, and now we have the confusion matrix.